Hi there. Look at the cheering crowd. It's an exciting match and the bowler is bowling some real quick deliveries. Let us check out what is happening on the pitch. Oh, look at his bowling pace. His last delivery clocked 160 km per hour. He has an average bowling speed of 146.4 km per hour. The average bowling speed, or the average of anything, is a central tendency, also called as the mean in statistical terms. Let us have a detailed look. Mean is a measure of central tendency. A measure of central tendency is a summary statistic that represents the center point or typical value of a dataset. Let us learn how to calculate mean. The mean is equal to the sum of all observations in the dataset divided by the number of observations in the dataset. So, if we have n values in a dataset and they have values x1, x2, and so on up to xn, the mean is denoted by x bar. X bar is equal to x1 plus x2 plus x3 and so on up to xn divided by the number of observations n. The sum of terms in the numerator, that is x1 plus x2 plus x3 and so on up to xn, is written using the Greek capital letter sigma or summation, which means sum of all x. Hence, mean can also be written as x bar equal to summation of x divided by number of observations n. Let's understand the properties of mean. The first property is the sum of deviations of an observation from its mean is always 0. Let us understand with the help of an example. Suppose we have to find the mean of 31, 33, 34, 37, 39 and 48. Its mean is calculated by applying the formula x bar equals the summation of x divided by the number of observations, that is x bar equals 37. Now the sum of difference of each observation and the mean is given as summation x minus x bar, which equals to 0. The second property is, if x bar is the mean of n number of observations, x1, x2, x3, so on up to xn, then the mean of observations x1 plus a, x2 plus a, x3 plus a, so on up to xn plus a is x bar plus a. It implies that if each observation under consideration is increased by quantity a, then the mean is also increased by the same quantity a. Let's take an example and understand. The mean of 31, 33, 34, 37, 39 and 48 is 37. If each observation is increased by 10, then the new observations are 41, 43, 44, 47, 49 and 58. Now let's compute the new mean with respect to these observations. The new mean is 47, which means it has increased by 10 as compared to the earlier mean. The third property is, if x bar is the mean of n number of observations, x1, x2, x3, and so on up to xn, then the mean of observations x1 minus a, x2 minus a, x3 minus a, and so on up to xn minus a is x bar minus a. It implies that if each observation under consideration is decreased by quantity a, then the mean is also decreased by the same quantity a. Example for this is, the mean of 31, 33, 34, 37, 39 and 48 is 37. If each observation is decreased by 10, then the new observations are 21, 23, 24, 27, 29 and 38. Now let's compute the new mean with respect to these observations. The new mean is 27, which means it has decreased by 10 as compared to the earlier mean. Phew, too much mathematics for now. Oh, it seems the fast bowler is on a hat trick. Let me go and enjoy it. See you next time.